So the strongest evidence that links PFAS with kidney diseases is actually between PFAS and renal cell carcinoma. So that's really the strongest link so far. And it's part of the reason that some PFAS have been listed as carcinogenic compounds. The research into how PFAS actually impact chronic kidney disease or diabetic kidney disease is a little bit less conclusive. And so, um, there's been some studies that are cross-sectional in humans that show that there is an association. There have been some animal studies that also demonstrate some pretty strong causal associations, but the links between PFAS exposure and chronic kidney disease, diabetic kidney disease is still something that needs more research.
Yeah, that's interesting. So, studies have found associations between PFAS exposure and the gut microbiome. And then studies have also looked at impacts of the gut microbiome and different things produced by the microbiome with kidney function. And so those two links have been shown in the past. And so we wanted to try and connect the dots with that and see if the microbiome could be mediating a relationship between PFAS exposure and kidney function.
Yeah, and I mean, to highlight that a little bit, um, there is this strong literature that's starting to emerge that shows that gut microbiome and the bacteria that actually live in your intestines can actually produce toxins or reduce toxins that are like nephrotoxic. So these uremic toxins. And um, we also completely separately have this body of literature that's showing that PFAS may actually alter the gut microbiome. And so together we kind of got this idea that there's maybe this link between PFAS, gut microbiome, these uremic toxins, and kidney function.
I guess overall, we found an association between increased exposure to a mixture of chemicals, of PFAS chemicals, and lower kidney function. And we found that that was mediated by alterations in gut microbacteria or gut bacteria and metabolites. Um, so that's kind of the overall findings that we found.
So, in a broader sense, this was the first study that has actually shown a link between these three different components: PFAS exposure, gut microbiome, and kidney function. And so, on one hand, we do have to mention that this is a small study. It's kind of a pilot study just for future work that needs to be done in this area. But it really is the first study to link all of these different components in this way. And it really suggests that the microbiome, the metabolites could actually be playing a really important role between this and this really common environmental factor and kidney disease. There's some work that's trying to examine in more detail the associations between PFAS and the gut microbiome. But in a larger sense, we know that these chemicals disrupt lipid metabolism. And so some of our previous work has actually shown that PFAS are associated with different levels of metabolites that are associated with lipid metabolism, not accounting for differences in gut microbiome. So, um, this is probably one of the mechanisms that's playing a big role. Um, we're also working on some experimental studies to actually try to dig in a little bit more onto the molecular mechanisms using technology like spatial omics or single cell sequencing data techniques.
Yeah, I think there's a couple things you can do with that. I think we know some of the sources that you can come in contact with in daily life. like nonstick cookware and food packaging from fast food restaurants and things like that. So I think that's one area where the general public can try and limit their exposure. In terms of clinicians, I think there's not really recommendations as of yet into ways that you can actually reduce your exposure. But I do think there are starting to be some filtration systems for things like water, which is a high exposure source of PFAS, where you can get water filters that you could put in your house. So I think there's a couple recommendations that we could provide to people if they are worried about exposure. Jesse, do you want to add to that?
Yeah. So since 2013, there have been, sorry. So since 2013, there have been more, there's been a lot more interest in actually measuring the levels of PFAS in drinking water. Traditionally, drinking water has been thought to be one of the primary sources of exposure to PFAS. And so now most major drinking water systems in the US actually provide information about contamination with PFAS compounds. Um, Oftentimes, even if they're found, there might be changes. So it's a little bit hard to actually link that with direct PFAS exposure. But as Hailey mentioned, in those places that do have drinking water, do have PFAS in drinking water, using these more advanced filtration techniques is really important. In terms of clinicians, the National Academies of Science, Engineering, and Medicine actually released a report a couple of years ago that talks about how PFAS exposure may be, how information on PFAS exposure may be used in clinical practice. It's now possible to actually get testing done on people's blood to measure PFAS exposures. And according to the NASEM guidelines, there's actually recommendations for clinical follow-up in people who have really high levels of these common PFAS. So that's been a really good resource, but we still don't know in people who have been exposed how to actually prevent damage or prevent toxicity from these chemicals. And so that's an area where we're working on doing more research. So maybe the last thing to add for context is that this study doesn't definitively prove that PFAS cause kidney disease. But it really starts to suggest um, that this is something we need to be aware of. And PFAS have been linked to other kidney diseases, like I mentioned, it's been linked to renal cell carcinoma. And so this is something that I think clinicians should really be aware of and start thinking about in terms of how do environmental factors actually impact kidney function.